All right, last video here, boys and girls. We're going to talk about suspension colloids, and we're going to talk about miscible versus immiscible. So suspensions, okay, suspensions are usually large particles, and they usually settle out of solution. So an example of a suspension would be like river water, okay? So let's go down here, there. So like river water, that's kind of the common one. So while the river water is actually moving and running, you'll notice that it's kind of dirty. Usually like the Mississippi or St. Croix, it's fairly stained. All right, but then when you take a scoop of it, say you put it in a cup of water and let it sit out, eventually all the sand and silt will settle to the bottom and the water will kind of rise to the top, so to speak. All right, so there'll be a separation. So river water would be a good example of suspension. Even orange juice with pulp would be another good example. Okay, OJ with pulp, because you have to shake it up to suspend it, and then if it's not there, then if you just leave it sit for a while, eventually the pulp will settle to the bottom. All right, so OJ with pulp. A colloid is medium-sized particles. All right, medium-sized particles, and there's something called the Tyndall effect. All right, so we'll talk about Tyndall effect here. So colloids, an example of a colloid would be something like milk. Okay, the white stuff you see in milk is not is fat. Okay, it's white particles of fat that's suspended in solution. So it's a colloid. You can see those. Another one would be like mayonnaise. I don't think I spelled that right. So mayonnaise would be an example of a colloid. You can see the particles. You can see the fat particles, the white stuff that's floating in solution. It doesn't settle out. Okay, and usually in a colloid, what you can do is you can shine a laser through it. And if you shine a laser through it, you can see the path of the laser. And if you can see the path, it's a colloid. If you can't see the path of the laser, it's a solution. All right. Speaking of solutions, small particles, you usually can't see with the naked eye. All right. And an example of a solution would be something like Kool-Aid or soda, things like that. You can see the stuff, but you can't see the particle size. Okay, it all looks like a pretty even mixture. All right, so there's some subtleties, some not so subtleties. Some are easy to see, some are not easy to see. But really, if they settle out, it's going to be a suspension. If they don't settle out, but you can see them, it's going to be a colloid. If you can't see the particles, it looks pretty even throughout. They're probably small particles. It's probably a solution. All right. So, and we'll do some examples in class to look on those things, and we'll look at the Tyndall effect and all those kind of things. So hopefully that helps you out there. Real easy stuff here for miscible versus immiscible. Miscible means it can mix or dissolve, however you want to view it. And immiscible means not mixing. All right. So example of something that can mix would be like obviously sugar and water. Sugar, water. Where something that won't mix would be like salad dressing. You have oil and water. All right, you get the layer, okay? So you get oil and water. So what things are affecting if it can mix or not mix? Okay, a couple things can affect those things. For example, the first thing that can affect if something can mix versus not mix would be temperature. Okay, obviously the hotter something is, the usually you can mix more. So let's say as temp, this is for solids and liquids. This is not for everyone, but most of them. As the temp increases, the solubility also increases. However, for gases, it's actually the opposite. As temp increases, the solubility, in other words, how much you can dissolve, decreases. All right. This is why if it gets too hot in the summer, they'll have fish die off, because all the oxygen in the lake will go away because you can't dissolve as much, and there'll be less oxygen for the fish. All right. Another thing that can affect temperature or solubility would be the pressure. Okay. In other words, the pressure around you, like the pressure you get when you dive down deep into the ocean, or you go, or the pressure that, or lack of pressure, say if you go high up in the atmosphere. So for gases, as the pressure increases, so too does the solubility. Okay? So it's a direct relationship. But for anything else, solids and liquids, for solids and liquids, pressure, not a big deal. It doesn't really affect it too much. Okay? So there are some things that can, but for gases, the pressure affects it, but for solids, liquids, gases, the pressure really doesn't affect it too much. The last thing would be the nature of the substance. Okay, and we're talking polar versus nonpolar. Okay, so in other words, if a compound has a charge, so likes dissolve likes. In other words, polar stuff dissolves polar things, and nonpolar stuff dissolves nonpolar things. This is why the salad dressing that we talked about up here is not mixable, because water is polar, oil is nonpolar. They are not the same. In other words, like dissolve likes. All right, so if something's not dissolving, it's likely because the polarity is not the same, or there's not, maybe the pressure or temperature is not in there. So those are some things that can affect solubility, and we'll work with some of those in class. So that was just a quick rundown of those things in class. Hopefully this helped. We'll talk to you soon.